Hi, everyone. Welcome to my portfolio critique. Oh, there it goes. For those of you that don't know me, I'm pretty sure everyone in here does. My name is Summer Vaughn. I am a double major in creative technologies and secondary education. And I got here through a mentor, Heikel Cooper, as many of you also know. He recommended to me to CRT because of my passions and desire to create, but also to instill that into other people. And that's kind of how I landed in creative technologies. And then through that, just being in the classes of creative tech and just enjoying learning and growing and how to iterate on designs, I was like, I really want to instill this passion and creativity into students. So that is why I declared secondary education as my other major. So at my time at Berry and Creative Technologies, just kind of reflecting on the projects that I've designed over my course at Berry. I have developed a theme that kind of explains some of my projects, which is designing experiential learning activities for STEM teachers. And the next 2 or 3 projects are going to kind of reflect that, and I'll talk through how it met this theme. The first project was in a class where our hope was to design rovers for students, but also to teach them the engineering design process. So that was the problem that we were trying to solve from the teacher's perspective, and for students to ultimately learn what the engineering process was, kind of how to iterate, how to give solutions, and then be able to test them and create better rovers. And we did that, like I said, through a simple rover to drop Skittles on a target to implement Mars. And through that, we were able, it was not just a day thing. It was definitely over the course of 6 to 8 weeks. So it took a little bit of time to kind of design what warm-up activities were going to look like, but also how are we going to teach these students to iterate, to come up with solutions over the course of a semester. So we did this through multiple different ways. This also was a group project, as you can see. And we developed lesson plans to kind of guide students' thinking through warm-up activities that kind of got them brainstorming. And then through that, we would help students kind of learn each step of the engineering design process, and that through that, we would then come up with better iterations, as you can see on the bottom right. Designs for students to kind of implement to create better rovers to ultimately provide us with the final product. The second project that reflects my theme of engaging experiential learning is It's Electric lesson plan that I've created. This was made within a hackathon, which is a 4-hour competition where you build something and then display at the end of it. So within those 4 hours, my goal or the problem that I was trying to solve was to teach, how can I teach 5th grade students circuits in a way that is both digitally engaging and hands-on engaging. So through that, I developed lesson slides to first introduce the topic, kind of get them a basic introduction of what a circuit is, how it works, what are the differences between conductors and insulators, and then also how does this relate to the real world. And through that, also pulling on their recall, being able to recall what are the components of a circuit to then be able to form one later on in the lesson. And then the second part that I designed was the physical part of building their own circuits using multiple different consumable and physical components like LEDs, things that are plastic and metal to kind of reiterate on those conductive and insulative products and materials. As well as helping them understand that there is a purpose for both batteries, but also how does electricity flow within a circuit. I also taught them the safeties within a circuit as well through this by showing them that if you wire just a wire through a battery, it will likely catch on fire over time. And although this is a little not intuitive in some ways, the line is supposed to be for conductive paint. So that the goal of that is to allow students to paint a line that simulates a wire, and then to connect those things within it to show that it is conductive or not conductive. And the final part of this lesson plan was to kind of show students a more online version of how a series circuit compares to a parallel. I feel like oftentimes fifth graders can't really visualize what that looks like. They just see a light. They're like, oh yeah, this works or doesn't work, but not necessarily that when two batteries are wired together in a parallel, it looks a lot different than it does in a series circuit, and kind of showing them the difference between that. Moving forward to my third project is the PBL puzzle, or problem-based learning puzzle. The intention of this was a lot more simple, to just kind of be more of a warm-up activity or like a brainstorming introduction activity. This one's also catered towards middle school students. And the purpose was to address the standard, as you see on the top right, to be able for students to explain the engineering design process. And through that, my goal was to design a puzzle that can also be laser cuttable for teachers to use as a resource, but also as a warm-up activity for them to kind of allow students to engage with the puzzle, but also in that same sense, be able to learn the engineering design process through engaging with the puzzle. And also helping them realize that the engineering design process can be difficult, can be hard, which is the purpose of the difficult pieces to kind of piece together to make it challenging, to help them bridge the gap between, oh, I do have to iterate a lot of times, I do have to test multiple times within the engineering design process to become a final prototype for the solution that I'm trying to solve. And again, this would be like a warm-up activity or like a brainstorming introduction activity. Moving on to my capstone project, which I feel also relates to my theme a lot, is Voices of STEM, Collaborative Design of STEM Curriculum for Third Grade Teachers. Going into my capstone, I felt like there was a big misconception or understanding that STEM was like this extra thing that needed to be carved out time for, or like a special curriculum that needed to be added on to what the teachers were already doing. So my goal was to help kind of understand what are the perceptions already, what are teachers already doing, what is making it seem like it's something that is almost impossible or hard to implement. So through that, I had 3 design goals. My first one was to develop or research about what has already been done, kind of how I can implement this through my capstone. The second part was unit development, which is developing the units. And then the third one was kind of displaying this in an exhibit to not only show teachers that I've done this with their feedback, but also to show them kind of get feedback on and show them what has been done and kind of get different advice on how to improve my capstone. So the first one, like I said, is research. Through this, I have developed a interview guide to kind of guide my time with the teachers. This was done through researching both what types of questions should I ask teachers, how direct should I be, but also open-ended, not just yes or no questions, which I'd done through my previous time. And then through that, I did a 30-minute interview with this interview guide to kind of get what are their perceptions already, what do they think STEM is. Through this process, I also realized that I should just ask them directly, what is STEM? I feel like at first I wasn't really getting to what I needed to get to. And so by the time I got through a couple of them, really the first one, I kind of iterated on my interview guide and was like, what is STEM to you? To kind of get that feedback, which was a lot more helpful. And then on the back of the interview guide, just kind of their feelings about STEM in general, the way that they talked about it. And then I also wanted to do a 30-minute observation, more informal, but also just to evaluate what is already being done in the classroom. Are the teachers already implementing STEM without really knowing that they're doing that, in the common words and themes that they were using? After that, I analyzed these themes through the teachers' feedback and just kind of found like common words and phrases that kept coming up, which is like experiential, collaborative, the learning's more connected, and then like science, the experiment part of it was something that they really continued to say throughout their interview, that students would get really excited. So using that research, I then decided to develop 4 unit plans, 1 per content area of the third graders, or the third grade teachers. And so the first one you see here is the math unit. And through that, I kind of took the ideas of, okay, they want it to be engaging, but also show that it does meet the standard already. So I pulled from the standard within the Georgia DOE and made slides for all of this, specifically addressing addition and subtraction with large numbers all the way up to 10,000. And so I did that by engaging students in a lesson that or developing a lesson that allowed them to build a Lego city with $10,000 as their budget. So they had $10,000 to work with. And then I also made outlines for the teacher to kind of guide their instruction of the unit plan. So what resources do they need? They're digitally given, as well as kind of a flow of how the lesson should go over the course of a week. The second one is the science unit. Similar to the other one, the lesson slides are all provided for the teachers, as well as supplementary materials, which I've created as well. This goes with either warm-up activities or the planning process of designing. So this one was to develop a solar water heater, which was the goal of one of their standards that I was trying to achieve in that. It's very hands-on. Students are allowed to engage with multiple different water heater sources. So like going outside some days to test the temperature, but then ultimately building a water heater to kind of show that heat absorption, vocab words like that, to kind of explain the process that they've used. And then as well as the first one, I also made an outline with links to these lessons as well. The third one was literacy. This one was catered towards the life cycle of the bee to integrate not only science, but also literacy, as you can see with lots of the other ones. But this one was to tell using sequence words and cause and effect words the life cycle of the bee, how the bees within the world have an effect on like flower development and things like that. So that was something that I developed as well to kind of use technology to allow students to not only code, but also use vocabulary and words to kind of guide the stage of the life cycle, which is also their standard. And then, like I said, the supplementary materials, so like a cut and paste to kind of visualize the life cycle, to then code a Bebot on a Bebot mat with cards, as you see on the other side, to kind of show the life cycle of the bee. Again, outlines for each of the units, displaying how teachers can edit and make this their own, but also to guide them in the instruction. And finally, social studies. This one was a little different. I ran into, during my interview and outline process, I realized that social studies and science is only taught for 20 minutes every day. So my goal with this one is to combine the two and help that in-between part where they only have 20 minutes, but would love to teach both at the same time. So this one is, it's a topographical map. They're going to create a topographical map to identify the features of the United States, but also within that, they're going to create their own salt dough to kind of sculpt the topographical map to show that those both can be very much integrated within the same unit. And then, as you can see, I've provided resources at the bottom, in which I've also outlined to the right, and asked teachers to make it their own as they teach certain features, because those features weren't specific within the standard. And then finally, to the last part, with the exhibit. So within those, I created 4 master copies of this unit plan to then present, as you can see on the right side, of the teachers within the STEM meeting that we had, which was the STEM, and like for each grade level, they have a STEM team. So I invited the STEM team, but I also created a invitation to kind of invite the whole school as well, to invite them, but also show them that this can be interactive. And through this, I did a presentation to kind of explain what this is. And then at the end, got great feedback on, is this doable? Is this something that you think that third grade teachers could do and implement? And then being able to present it to teachers that are veterans and new teachers to kind of get different feedback on that. And through this, I also was able to make a Google Drive to share all of the teachers that had participated in this. I gave that to them so that they can have digital access, but also a physical access. So moving on to my impact, I was able to make each of the third grade teachers that participated within my capstone project received a binder with their content printed out so that they could reference it anytime they needed, and each copy of the supplementary materials so that if the internet was down or whatever, they had a copy of that to use themselves. So being able to provide unit curriculum for each of the third grade teachers was part of my impact, as well as connecting with teachers, kind of in that exhibit, being able to show that their voices of STEM, whether that's third grade or fifth grade or whatever, specifically mine was third grade, but showing them that their insight is valuable into the development of curriculum, and showing that through these connections, these STEM units were actually improved and able to be now used by them at their convenience. So what's next? I have accepted an engineering and technology teacher resident position at Mill Creek High School in Gwinnett County. I'm super excited, and it's funny because it's high school, I know, but I'm excited to see what happens. And I think I can scale these up if needed to kind of fit, because engineering process is everywhere. So, and then get married in November. So yay, that's me.